All right, we are on 1.7 day 3 today. We're going to be talking more about modeling with functions. Today we're going to be focusing on translating a lot. Okay, so when you're asked to write a mathematical expression from a verbal description, translate the words into a math expression, and then if you're asked to solve it, plug in the values if you need to and solve it. A couple of hints: always use decimal equivalents for percentages. So if they give you 28%, that would be 0.28 in decimal form. A percent drop means you're taking it away from 100%. A percent added means you're adding it to 100%. Profit is the amount made minus any cost that it took you to start. Comparing offers means set the offers equal to each other and solve, like a system. Percent increase or decrease, if you don't remember, your proportion for that is the difference over the original equals the percent of change over 100. Cross multiply, divide to solve. Mixture problems, here's a handy dandy formula which will make more sense to us when we get to an example. Anytime you're asked to find a maximum value and you have an equation, you can type it in the calculator and use the calculate the maximum function. Unit conversion, it's similar. It is unit conversion. It's like switching inches to feet or miles to feet. It's just that we're going to be converting rotations per certain unit of a time to another unit. Again, that'll make more sense when we get to it. So starting off, they're going to give you some very simple ones to translate. It says 5 more than 3 times the number x. If I translate that, 5 is easy. More than would be plus. 3 times the number x would be 3 touching x. Done. Okay, next, a number y decreased by 10 and then quadrupled. So I can translate this into y. Decreased by means minus 10. Now, then quadrupled means this whole difference is quadrupled. So you need to put that in parentheses and then quadruple it by 4. And that's translated. If you're asked to simplify it, you could go ahead and distribute and get 4y minus 40. Okay, next we have 23% of a number x. The word of in math most of the time means multiply. So it's saying take 23%, but we write it as a decimal, and multiply it by a number x, which would be 0.23x, 0 in the front. All right. Last on this slide, we have 20 less than, well, I should say 20 less than 34% of a number x. This is a trick. If you write 20 minus 0.34x, you're backwards. Less than does mean subtract, but it means you're subtracting 20 from the 34% times x. So this is backwards. It should be written 0.34x minus 20. Put a 0 in front. Don't leave your decimals naked. Okay, you're too young to see that. All right, so pause and translate. And we're back. And hopefully you answered 1. A number x decreased by minus 5. And then that means everything you've done up to that point is doubled. Okay. Some more. It says the area of a rectangle whose length is 12 more than its width. Okay, so we have to write a mathematical expression where we know how to write area of a rectangle. Area of a rectangle is length times width. But in my particular rectangle, they're telling me that my length is, that's equals, 12 more than, that's 12 plus, its width, but they're telling me to call the width what? X, correct? And for my width, they told me to call W equals X. So now all I have to do is substitute I have area equals my length, which is 12 plus x, times my width, which is x. And again, you've translated it. Area equals length times width. You've translated it. If you had to simplify, you could distribute and get area equals 12x plus x squared. Both of these would be correct. Okay. Next, we have the area of a triangle whose altitude is 5 less than its base length r. So I'm going to draw me a quick triangle. Or I guess I should write our formula. Area of a triangle is 1/2 base times height. Okay, they also call the height the altitude. All right, so it says, it says the area of a triangle whose altitude, that means its height, so that altitude or that height is 5 less than, here's my trick again, so I've got to take 5 away from its base length r. So they're telling me to call the base r. Yes? And here's my base, but they told me to call it r. So now if I replace my b and my h with how I just defined it, okay, the area is 1/2 my base, but they told me to call that r, times my height, which they told me to call r minus 5. And you have translated it. If you had to simplify that, I would distribute my r, and then I would multiply by 1/2. But I think you just have to translate it, and that's all they want. Okay? Next, we're talking about salary. Okay, and it says a salary after a 3.8% increase if the original salary is $y. So you're getting a raise. Okay, yes, you're getting a 3.8% increase. A 3.8% of, remember that means times, your original salary. So you're going to still make your salary, but you're going to add to it your increase. And remember, we want to write our our percents as decimals, so move it twice over. This would be 0.038 times y. Here's my original salary. I'm not going to, if you just put 0.038, you're making 4 cents extra. Okay? But it's not, you're not making just 0.038 cents, you're making 0.038% of, which means times, your original salary, which we called y. So there's your original price plus your increase, and that would represent the total salary. Okay? The next one, we're losing some money. Okay, the next one says that your income after a 12% drop in the current income of G dollars. You're not just going to lose 0.12 cents. You're losing 12% of your G dollars. And you're taking that away from your original income. Okay, so my income, my total salary, after a 12% drop of my original from my original. To find your total income, you'd have to take your original salary and subtract 12% of it. Make sense? I hope. Oops, sorry, did that again. It gets stuck. Give me a second. There we go. All right. Sale price of an item marked P dollars if 20% is discounted from the marked price. So we're not going to be paying more. We're going to be paying less. We're not going to pay the full price. We're going to take some money off of that. How much are we going to take off? 27% of the original price. So I'm not just taking off 27 cents. I'm taking off 27% of the same price. That would equal my sale price. Okay. Last one, sales tax. You know you don't go into a store and buy anything for what it says. You got to pay tax on it. All right. So the actual cost of an item selling for B dollars. You go up to the register, you don't just get to give them B dollars. It's going to cost you extra. How much extra? You're going to add this much percent of the original price. Again, that means times, but we need a decimal. So that would be 0.0674 touching B. That would be my final cost. You don't just get to pay the price on the ticket. You're going to have to pay 6.74% of that price more. Okay? Alright, so I'm going to hit pause, or you hit pause, work the problem, and we're back. And hopefully you got number 1. And again, it says the area of a triangle, so I'm going to draw my triangle, whose altitude, and remember area of a triangle is area equals 1/2 base times height. And it says my height, they use altitude, but it's height, so they're telling me this equals 5 more than its base, which they said to call it x. So they told me call bx, the base is called x, and the height is 5 more than that. So then you just substitute it in. Area equals 1/2, but instead of base, I'm going to put x, and instead of height, I'm going to put 5 plus x. Yes? Okay, hit pause and answer. And we're back. Hopefully you got number 1. Oh. Let me talk about this a little bit. I probably just tricked you there. All right, sale price of an item marked X dollars if 35% is discounted from the marked price. So if I had X dollars to begin with, but I'm not going to pay that, that's on the ticket, I'm going to get some money off, so I'm taking some away. 35% of that price, so 0.35x. That would be an acceptable answer. Notice that that's not one of them there. All they did to get this answer was simplify this one. Okay, there's 1x here, take away 0.35x's. If you take 1.00 and subtract 0.35, 0, borrow, carry, you get 5, 6 point, this simplifies down to 0.65x. That'll be the sale price. This isn't wrong, they're just giving you the simplified answer to it. Alright, push pause and work the problem, and we're back. Hopefully you got number 3. If not, let's look why. The profit consisted of a franchise fee. Profit is what you get, so we're talking to the good. Alright, the profit consists of a franchise fee of $100,000 plus 18% of all sales. There's that word of again, and I don't know how much I'm going to sell, so that's going to be the I don't know. So I'm going to get $100,000 for a franchise fee plus 0.18 of all sales, and I don't know what my sales are, so I call it X. And then again, this isn't wrong, they just wrote it with the variable in front of the constant. Okay? Alright, it says one leg of a right triangle is 4 times as long as the other. Write the length of the hypotenuse as a function of the length of the shorter leg. What that means is, to get the hypotenuse alone, they want you to write the length of a hypotenuse, so they want h on one side as a function of the length of the shorter leg. Okay? Well, in a right triangle, you know that leg squared plus leg squared equals hypotenuse squared, correct? But what it tells me is that I have one leg longer than the other, correct? So if it says one leg is 4 times as long as the other, so if I call the short one X, okay, then the longer one has to be 4 times that, which would be 4x. Make sense? So now when we plug those in, instead of leg squared, I'm going to say x squared plus the other leg squared would be 4x squared equals hypotenuse squared. Now, they want me to write, I'm done. I mean, I've substituted everything in. I need to simplify, but then it says get hypotenuse alone, which means I've got to get rid of that square. But I've got to take care of this side first. Okay, so if I square this 4x, that means 4 gets squared and x gets squared, because that means 4x times 4x, which is 16x squared, plus this x squared equals the hypotenuse squared. Okay, I can combine x squareds, and that would give me 17x squared equals the hypotenuse squared. And then finally, to get h alone, I'm going to take the square root of both sides. So h would equal, 17 is prime, you can't break it down, but the square root of x squared is x. So x would get out, and you'd have the height is x square roots of 17. Did I write it as a function of the shorter leg, which we called x? Yes. Okay. All right. This one. It says a square is inscribed in a circle. Find the length of each side of the square, and then write the perimeter of the square as a function of the radius of the circle. So we're talking about they want us to write the perimeter of a square. I know how to do perimeter of a square. It's 4 sides. Side plus side plus side plus side, but that's going to be 4 sides. So there's my formula. The problem is they want P alone, but they don't want me to use S. They want me to use the radius of this circle that it's inscribed in. So let's look at a picture here. Okay, I have this circle. Okay, and, oops, sorry. I have this circle, and I have a square inside of it. Would you agree that if the square is inscribed inside the circle, they share the same center? Okay, if they share the same center, then would you agree from here to here is the radius of the circle? Great. Okay, unfortunately, the radius of the circle is not the same thing as one of my sides of my square. Otherwise, I could just replace S with R and be done. Somehow I've got to figure out the length of that side. Well, I noticed that if I draw this line right here, isn't that also a radius? And this side is also a radius, correct? And there's a theorem that says if 2 sides of a triangle are equal, the triangle is isosceles. Okay? Which further means that whatever the height of the triangle is, this length is half of the length of the base. Okay? Which means that this length is the same as this length. Does that make sense? Because this length here would be half of the whole bottom, and this would be half of the bottom. So they have equal sides. Does that make sense? Okay, hopefully. Now, this would be the length of the side that I want, correct? Well, I noticed that I have a right triangle here. See how I have this right triangle here? Which if I solved that, I could figure out what this is. If I can figure out what this is, I can double it, and then I can figure out what this whole side is. And if I can figure out what that is, I can substitute it in here, and we're done. So, let's use our handy-dandy right triangle. Pythagorean theorem. The leg squared plus the other leg squared has got to equal the radius squared. Agreed? If I simplify, that's going to be 2L squared equals R squared. Again, I'm trying to figure out what L is. So right now I want to get L alone. So first I'm going to divide by 2. That gives me L squared equals R squared over 2. To get rid of the square, I'm going to take a square root, but I have to do it to both sides. And that gives me L equals, if I square root the top, the square root of R squared is R. Square root of 2 I can't do. Now, I need to rationalize that, but I'm just going to wait till the end. Okay? Now, that's not the whole length of a side, that's just half of the side. To get the whole side, I need 2 lengths put together. So I need to multiply both sides by 2. I don't want to know what L is. I want to know what 2 times L is. But if I do that to that side, I've got to multiply by 2 on the other side. So this would give me 2L equals 2R over the square root of 2. Correct? And didn't we just decide that 2 L's equal a side? We did. So therefore, I can say that a side is equal to 2R square roots of 2. Now I need to rationalize that. You can't leave a radical in the denominator. So multiply by the square root of 2, multiply by the square root of 2, and you get a side is equal to 2 square roots of 2R all over 2, which those 2's will then cancel, and I can say that a side is the square root of 2R. Correct? So now that I know what S is, I can plug it in here into my formula, which says perimeter equals 4 times S. But again, they want P alone. I have it, but they don't want it in terms of S. They want it in terms of R, which is why I had to do all this. I can now replace that that S with, I can replace that S with the square root of 2R. Bring down everything else. So I have P equals 4 times the square root of 2R. Distribute, and I get perimeter equals 4 square roots of 2R. Done. I found a mathematical expression to describe the perimeter of that square in terms of the radius of that circle. Okay? Next. Okay, this one hit pause, work the problem. And we're back. And the answer would be 3. So let's look at y. Alright, I have one leg of a right triangle is 3 times as long as the other. So if this is my short one, my long one is 3 times that. And this is my hypotenuse, correct? Write the length of the hypotenuse as a function of the length of the shorter leg, which means I need to get h on one side and x on the other. So my Pythagorean theorem says leg squared plus leg squared equals hypotenuse squared. As I simplify, that's going to be x squared plus 9x squared, because 3 squared is 9, and x squared is x squared, equals hypotenuse squared. Combine like terms, that would give me 10x squared equals hypotenuse squared. Then we're going to kill the square by taking the square root. So the hypotenuse would be, again, square root of 10 can't be simplified, but the square root of x squared is x. Now they used c instead of h and they used a instead of x, but that's my hypotenuse. You know, they usually use a, b, and c, I don't. And my a was my shorter side, which I called x instead. Alright. Here's a nice one. These ones are the most difficult. I'm sorry, hit pause. Work it. And we're back. Okay, we've got a square inscribed in a circle. If you give my drawing, that's why I used clip art on the other one. So we've got a square inscribed in a circle. And now it says, this one's a little bit different. This one says write the area of a square. The area of a square is a side squared. In other words, side times side, but in a square they're equal, length times width, but in a square they're equal, so we call it area equals side squared. But they want area on this side, but they don't want it in terms of S, they want it in terms of R. So similar to what we did before, I know that I've got to figure out the length of this side of the square. Well, to do that, I'm going to go from the center down. There's a radius. There's a radius. Since radiuses are equal, I know that's isosceles. Since I know that's isosceles, this length has to be the same as this length, correct? So we go leg squared plus leg squared equals hypotenuse squared. Okay, we're going to combine and we get 2L squared equals R squared. Again, I'm trying to figure out what L is, so I'm trying to get L alone. So I'm going to divide by 2, divide by 2. I get L squared equals R squared over 2. Kill the square by taking the square root of both sides. I get L equals the square root of R squared on top is R over the square root of 2. Okay, so now I know what L is, but that's not the length of the side, that's only half of it. So to get the other half of it, I need to double this. So multiply both sides by 2, and I get 2L equals 2R over the square root of 2. Okay. But now, don't we know that 2L is the same as one side of the square? We do. So can't I replace 2L with S equals, and I need to rationalize. So square root of 2, square root of 2, I would get 2 square roots of 2R over 2. The 2's would cancel, and I get side equals the square root of 2R. So now I can replace this, just the side. I still have area equals side squared, but now I know what a side is. A side is the square root of 2R. When I square that, I square them both. The square root of 2 squared is 2, and R squared is R squared. So now I have area in terms of the area of the square in terms of the radius of the circle. Pretty cool? Alright. So, how can you identify which of the 12 basic functions most appropriately model real-world situations? We didn't necessarily talk about the 12 basic functions today. That's going to come more tomorrow. But we used formulas and things that, area of a triangle, area of a rectangle. We use those sort of mathematical models. Okay? And then you're on to your homework. So have a wonderful day, and we will see you next time.